Hello and welcome to another math tutorial. This week we shall start something with we shall start with something that's quite a bit more complicated. Uh, Probably a bit more complicated than things we've done in the past. Because you got trig, you got log, and probably don't even know what that means. But I thought this would be a pretty cool way to do an overview of all the things that we could cover in the future. So let's get right into it. So we are asked to prove that log of tangent of theta over 2 plus pi over 4 equals half log times half log of 1 plus sine theta over 1 minus sine theta. Okay, so how would we even go about doing this? Well, the first thing we notice, everything is in radians, and we see, and the reason is we have pi over 4 here, and for which, if we do the conversion properly, this is equal to 45 degrees. But that's not really important. So, and the key is that the angle is also in radians. So yeah. So when we're doing these proofs, we want to remember to always start with the side that looks more complicated. Well, this side probably looks more complicated, right? So let's go ahead and see what we can do. So we can have the left-hand side. All right, we have log of tangent. Actually, okay, before we do that, all right, before we do that, we're gonna see if we can manipulate this a little bit. So we know from the power rule, or whatever it's called, if there is a constant at the front of a log expression, we can take this and put it as the power. So this is going to be log of 1 plus sine theta over 1. And then this is going to be raised to the power 1/2, which we all know is also a square root. So essentially, we want to show that this expression is equal to the square root of 1 plus sine theta over 1 minus sine theta. And so that's our goal to the end of this video. Now, so in fact, we're just going to erase that now. And we're just going to start with the left-hand side. And the left-hand side, we're gonna manipulate this side. All right. So I'm gonna use pen because it's easier to see. So we're just gonna go ahead, and you'll notice this is the tangent of two angles. And when we have the tangent of two angles, we can use what's called the sum rule. The addition of angles. The formula for the addition of angles for the tangent function. And we know that that is equal to so we have tangent of the first, okay, plus the tangent of the second over 1 minus so that's that. And, well, we can simplify this, right? So we have tangent theta over 2 plus, well, this is the same as tangent of 45 degrees, which we learned before is 1 over 1 minus tangent theta over 2. Okay, so well, I promised in the beginning that our objective is to make this simpler. I mean, this doesn't look any simpler. This is probably worse. So what we now need is the half angle identity for the tangent function. And to do that, we're going to use the half angle identities for sine and cosine. So the way we do that is, so we have, I'm just going to write down the half angle identities for sine and cosine. So sine of theta over 2 is equal to is equal to the square root of is the square root of 1 plus cosine theta. And we have cosine theta over 2, which is just the square root. Oh, this is actually over 2. So 1 minus cosine. And so to find tangent of theta over 2, so I'm just going to put a line. We're just going to go ahead and divide. So we have sine over 2. So since we're dividing, we're supposed to, so we have sine of theta over 2 or cosine of theta over 2. And that is equal to the square root of 1 plus over so now, so how can we simplify this? Well, we definitely don't want to put the square root inside of there, right? So what we want to do is we're going to try to get rid of the square root. And the way we're going to do that is, well, so we're going to multiply the top and bottom by 1 minus 1 plus cosine squared. And we all know that that doesn't actually change anything, right? Because this is the same thing as multiplying by 1. But if we do that, we get the square root of 1 plus cosine theta squared over, and here we see that this is the difference of squares. So we have 1 minus cosine squared theta. And from here, we see that this is 1 plus cosine squared theta. And this is the same as sine squared theta. So therefore, tangent is actually equal to 1 plus cosine over sine.